Good morning, everyone. We're ready to start? Okay. Yes, good morning, everyone, or even in the afternoon or evening, depending on where you find yourself in the world. We warmly welcome you to our latest Novogene webinar. My name is Seamus. I'm one of the senior account managers here at Novogene, and I'll be your host today. I'm just really glad to introduce you to our webinar today, which is entitled The Risk of Use of Domestic Laundry Machines in Decontaminating Healthcare Uniforms. And we're presenting the work of Professor Katie Laird and Dr. Caroline Carew, and they detail how domestic laundering sometimes contributes to antibiotic resistance and hospital-acquired infections due to the survival of bacteria on textiles of healthcare staff. Sorry, I'm just trying to move the next page. Sorry, this isn't. Sorry, I'm just trying to move to the next slide. It's kind of stuck a little. Oh, sorry. Here we go. And this is the latest in our series of webinars. And it's part of our Genomic Research Live service. And this is our platform to bring scientists and researchers together from around the world. And we're pleased to remind you that I say that all of our webinars from all of our series, including our very popular beginners series to lots of our different services, these are all available on our website. And in terms of, and as you said, you can access these whenever you like. And also in terms of this webinar will also be part of that series after this event. So just a couple of housekeeping rules before we start. In terms of it, the presentation itself will be about 40 minutes, and there will be a kind of question and answer element post that. Now, again, if you wish to ask questions in terms of, please use the Q&A element, the feature, which is located on the bottom of your screens. And as you said, if you send that through, that will go through our staff who will put these questions through to the speaker. And I said anything that that is unanswered, we will pass to you afterwards in terms of we will get in touch with you and kind of try and answer everything as thoroughly as possible. So please don't use the raise hand functionality. Just use the Q&A section to add a question. We'll send the slides through to everybody after the meeting. And in terms of, we'll send a recording of this. That should be ready in the next day or two. And as you said, we'll be able to share that with everyone as well. So what I'll do firstly is just give an overview of the company. So Novogene is global. It was founded in Beijing, but we have 10 laboratories and 19 subsidiaries around the world. So our business covers around 90 countries and 6 continents, so we are truly global. We have 2 European labs, and we have the Science Park in Cambridge for your UK staff, for our UK customers, but also a new laboratory in Munich in Germany as well, where a lot of our EU customers send their samples. And we have a range of services, including, let's say, whole genome sequencing for human and whole exome sequencing for human. We have transcriptome analysis, let's say, for prokaryotic and eukaryotic species, including poly-A and ribosomal RNA depletion library preps. We have our webinar today focuses on microbial work in terms of, so we do a lot of, let's say, microbial whole genome sequencing, metagenomic sequencing, amplicon sequencing. We have an epigenomic services, including whole genome bisulfate sequencing, ChIP-seq and RIP-seq. We do, let's say, let's say, plant and animal sequencing, and also we've started a proteomics service as well. So why indeed Novogene is important going forward is and also why we're kind of a global and respected service provider in terms of our reliable results, in terms of samples past QC. They have set data guarantees. We have large capacity with large number of platforms to run your samples on, and the latest technology of these platforms, including the NovaSeq X Plus, the PacBio Revio, and the Nanopore Promethean. We're a fast turnaround. We can process samples really quickly, and we also kind of to set times. And as you said, our large scope of platforms means we can take projects as big or small as you like, and also as you said, we also have dedicated staff, let's say pre and post sequencing, to help with your research specifications. We're throughout Europe. We have local representatives across the UK, Ireland, and Western Europe, and Eastern Europe as well. So in terms of wherever you are, whether it's Southern Spain or Northern Germany, we can please get in touch, and we'll have a local rep for you who can come and speak with you. So I'll just give an introduction to our speakers today for their who've kindly given their time. Katie Laird is a professor of microbiology and deputy director of the Institute for Pharmaceutical and Health Innovations at the School of Pharmacy at De Montfort University in Leicester. And again, Katie and Caroline are going to be talking about their work today, which again, key elements of it is, let's say, looking at hospital-acquired infections that can be occurred through healthcare laundry. They also are interested in biofilms and novel microbials. But I'll pass them to you now, and we're really excited to hear about their research. Sorry.
Thank you, Seamus, for the introduction. So as Seamus said, I'm Professor Katie Laird, and I've been working in looking at textiles as fomites for over 10 years now. Because in the UK, mainly, nurses' uniforms are laundered domestically. So the microorganisms that those uniforms are contaminated with are being taken into the home environment. Now, this isn't necessarily the same in Europe, where they are industrially laundered. So the risk needed to be understood, and that's what led to this research. So if I can have next slide, Seamus, please. So we're going to, back one. So today we're going to discuss the survival of bacteria on textiles, the disinfection efficacy of the domestic washing machine, but also more scarily, I suppose, when we look at the data, is the contribution that those domestic machines can make to antibiotic resistance in the environment. Next slide, please. So as I mentioned, in the UK and US, domestic laundry machines are commonly used to clean healthcare worker uniforms, and understanding the role, one, in decontamination of those textiles coming from the hospital home and then back into the hospital environment, but also in the role of AMR. But there's other things to consider, things like care homes, GPs, veterinary services, dental services, which even in Europe are generally laundered in domestic machines. Next slide, please. So quite a few years ago, the first question we needed to answer was, does bacteria survive on textiles, and how long does it survive for? So we took E. coli and S. aureus as a gram-positive and gram-negative bacteria, and we took polyester and cotton fibres, and we literally looked how they survived over a 21-day period. Now, as you can see from this graph, both microorganisms survive much better on cotton for a longer period of time, and that they were still surviving and living quite well at 21 days. Now, we believe this is because of the nutrients availability in this natural fibre, and also the moisture availability. And one of the key things is that with cotton fibres, that the bacteria are actually absorbed into that fibre, compared to the polyester, where they remain on the surface, which actually, although looking at this, we were up to about 7 days here, which is the red line, the purple line, before we start seeing a considerable drop off of the microorganisms. The ability for these bacteria to transfer onto other surfaces is greater on the polyester, because it is just sitting on the surface and can transfer, compared to where it's been more readily absorbed in those cotton fibres. Next slide, please. So here we looked using the SEM just to see what was happening with these bacteria that was surviving over these different periods of time. And you can very clearly see in the first two image columns, the E. coli is present. But as I mentioned, on the polyester, it's much more sparse and just sitting on top of the fibre, whereas you can see within the cotton ones, it's starting to bundle together, maybe even form some type of biofilm. And I think this is particularly shown on the S. aureus, which is the third column of the the images on the cotton, where you can see real clumping there. So the bacteria was quite happy on these fibres for a long period of time, and I think that's the important message that we take from this. Okay, next slide, please. So then what we wanted to understand is what was the transmission during laundering. The NHS guidelines say wash at 60 degrees with detergent, which if you do that, that does remove the bacteria. However, a large survey we did back in 2015, which we actually then repeated during the pandemic, showed that most nurses were washing at 40 degrees, and they were washing with other items of clothing, which again, the NHS guidelines states that they shouldn't. But if we think about a busy nurse with limited uniforms, a family, the energy costs of washing, I mean, it's not really surprising that they're not taking on that additional cost of washing individual uniforms at 60 degrees. So what we did was we took swatches of polycotton and polyester, contaminated them with E. coli and Staphylococcus aureus, and we put them into a wash at 40 degrees, but we also put some sterile swatches into that wash as well to see what was happening. And very clearly you can see here that the bacteria is surviving, but not only is the bacteria surviving, it's transferring onto the sterile swatches in the wash. So at 40 degrees, where the temperature isn't killing the microorganisms, it's basically being moved around the washing machine and being transported onto other items of clothing in the wash and still coming out of the machine contaminated. Next slide, please. Now, it's not just me that's saying this. It's well documented in the literature. So there's a table here of lots of different studies that once you've got the recording, if you want to look at some of these, you can in more depth. But what this is really showing is that a range of microorganisms, from gram-negatives, gram-positives, yeasts and viruses, are all able to survive on a range of different textiles and garments over a period of time. And obviously we have the above the elbow policy within clinical settings, so that cuffs and things are not touching the patient and potentially transferring. Next slide. But what that's also is shown is that microorganisms are readily able to transfer from textiles to skin, stainless steel, vinyl flooring, surgical gowns, and lots more. And again, I've given a table here of the different microorganisms and the different studies that are showing this. So if you are interested in this, again, you can have a look at some of these studies that are showing this transfer. And one I didn't mention there is C. difficile spores. Now, we've done a couple of large studies on this from ward to washer, actually, showing the C. difficile spores are surviving both domestic and industrial washing. And obviously that's a real problem, and how they attach is also an issue. But we that is published and you can have a look at that, not the discussion for today. Okay, next slide, please. So the more recent study that we did then was aiming to look at what was happening within domestic washing machines that were at 60. Were these machines performing? Were they maintaining temperature? Were they doing what they said on the package? Some of my other research has been developing bioindicators for the global industrial laundry industry to look at kills within wash. So we use this technology, which is the image on the left-hand side, where you can see the different logs of the bacteria. And that's basically a bioindicator that's got a membrane and is sectioned off with the different logs of bacteria, and they're on cotton swatches in there. And what the membrane does is it allows the chemistry, the temperature of the water to pass through, but not the bacteria to escape, which gives us a true understanding of kill in the wash. So we use this these bioindicators to look at a range of domestic machines, and because we obviously wanted it done in a with microbiology specialists do them. I roped in every microbiologist in the building and asked them to do the tests on their home machines. So we were particularly looking at 60 degrees because this is the temperature that is recommended by the NHS and we know kills, to have a look at the performance of these machines. So we looked at full length cycles and we also looked at the rapid eco washes. Like if you're anything like me, a busy mum with a boy that plays lots of rugby, so lots of dirty clothes, then the eco cycles or those rapid cycles are a lifesaver, and we all use them readily. So how were they performing? And we looked at it with biological detergent and non-biological detergent. And the microorganism we used was Enterococcus faecium, and the reason for using this microorganism is that they're thermotolerant. So we knew that they were a good organism to survive these types of the temperatures without being killed off at much lower temperatures. Okay, next slide, please. So the machines that we tested, there was a range of different makes, models, and also the age of the machines as well, which we will come back to, that has quite a significant effect on this. So next slide, please. So the full length cycles then, they had a range of different times on them. So ranging from around 2 hours up to 3 hours, 5 minutes. So I don't know who's got time to wait for 3 hours for their washing load, but this machine particularly, their full length cycle was just over 3 hours. And we looked at the profile of temperatures. We used an I button that you can put into the washing machine so we could look at the profile of the temperature as well as the kill of the microorganisms with them in the machine. And I think, Seamus, if you click again, some red circles should come up. Or some green ones, we'll do the red ones in a moment. What we were seeing here was that 3 of the machines, so 50% of the machines we tested actually reached near enough to the temperature and held for 10 minutes. So it's 10 minutes at 60 that was required to decontaminate the microorganisms. But of those machines, 3 were also failing. So some of them were reaching temperature, but not for long enough. And then number 6, well, that just stayed at 20 degrees regardless. So my poor colleague had to go and buy a new washing machine. But I think what was the message here is he thought that his laundry was being washed at 60 degrees and had absolutely no idea that actually it wasn't raising temperature at all. And one of the key things that we did see during this research is the age of the machine makes quite a lot of difference. So if you look at those that are failing, they are older machines. So this is something that really needs to be considered. But we need to think about how many people know that their temperature is being reached, know what level of water, so how much disinfectant to put into the machine, how much to dose the machine, and also what their holding time. This information is just not available on domestic machines. Next slide, please. So then we moved on to the rapid cycles or the eco washes. Now, the rapid cycle on the older machine was still 2 hours, and actually on the machine 5 was 2.5 hours as well, so not so rapid. But we looked at the temperatures and we started to see much more lack of temperature being held for the time period required. So I think if you press again, Seamus, we should get some more coloured rings. So at this point, we only had 2 machines that actually passed the test as in 60 for 10. And we were down to 4 of those machines now not reaching temperature or not holding time. And realistically, if we look here, 20 degrees, 45 degrees, 30 degrees, they're nowhere near the 60 degrees that somebody thinks they've set their domestic machine to. Next slide, please. So then that was looking at the performance of the machine against what the user thought they were achieving. And then we obviously looked at the microbiological kill within those washes. So you can see here the 6 different machines again, and we have the full length ones at 60 degrees and the rapid at the bottom with both the biological and non-biological. So with the full cycle, despite 3 of the machines failing, we only had 2 that failed microbiology. Well, I say only 2, we shouldn't have any, should we? But we had 2 failing. But once we moved into those rapid cycles, we were seeing that really 4 out of the 6 machines were failing to decontaminate the bioindicators, which is rather worrying, really, when you think about those textiles coming in from clinical settings into the domestic setting and back out again. Okay, next slide, please. So we knew at this point that the domestic machines, even if you're using 60 degrees with detergent, was not decontaminating, was not performing. So then what was the risk of the actual laundry machine to the transmission to the textiles being fomites, even the machines being fomites, for microorganisms, but also we were particularly interested in antibiotic resistance as well. So the same machine, well, we did the same machines, but I'm very pleased to say that I disinfect my machine quite regularly. So we were unable to get enough off of my machine, so we had to adopt some more machines in there. We looked at the biofilm sampling from in the rubber part of the drum, but also the pipe that goes behind the drawer. So if you pull your drawer out, your detergent drawer out, behind the pipe behind there. So we did some DNA extraction. We then sent the samples off to Novogene, who did the shotgun metagenomic sequencing for us. Okay, next slide, please. So the data analysis that they did is here, and we were looking at taxonomy annotation, function annotation, and of the resistant genes as well. So this is all the information that we wanted from the samples that we'd sent off, so we could fully understand what was happening within those biofilms of those machines that we knew were not decontaminating textiles. Next slide, please. So what we found then, we found quite a lot, really. We had a number of bacterial, so we've broken this down into bacterial classes and genesis. And we've put the 10 most abundant here, but there was many, many more. So you can see such a range of different microorganisms from all the different samples. But you have got some in there that we are known to be have pathogenic species within them. So the Pseudomonas, the Mycobacteriums, were all in there. They did vary between machines. But it was quite variable between machines, which was interesting. So it could be to do with the water that's coming in as well. Let's not forget that, because we've got different water hardnesses coming in and the survival. There's certainly a large range of bacteria there. Oh, next slide, you're right. I read my mind there, Seamus. So the next thing that we were really interested in was the antibiotic resistant genes and what they were harbouring, and was this something that potentially could be contributing to the whole antibiotic resistance profile. So we found a number of those genes in there, mainly associated with efflux pumps, which maybe you would expect. But if you look at QACG here, they were disinfectant agents and antiseptics, which wasn't surprising when we think about the detergents going into the machines. And I think the key thing when we're talking about domestic washing, unlike industrial laundering or on-premises laundering, is which detergent do we put in? Are we putting the correct amount in? So it is really important when we looked at this to think about, well, are these sublethal doses that are allowing tolerance to occur, and these, and the switching on of these antibiotic resistant genes. So we've also got some target alteration genes in there, but there was quite a range of different genes, which was rather worrying. These were only the 10 most frequent ones, I might add. Okay, next slide, please. So when we look at the abundance of the different genes across the different samples, the different machines, and so you've got the pipe and you've got the rubber, you can see those different relatively different quantities. So that ANT3, which is the blue region, there's quite a lot across all samples in there, whereas some of the others are quite varied. We see a fair amount of the orange as well, which is the QACG, which I mentioned, is the efflux pump based on detergents resistance. So you'd almost expect to see that there, but we were quite surprised by this, the number and the patterns that we were starting to see that these domestic machines were harbouring. Next slide, please. So the next part of the study was to look at this detergent disinfection resistance and cross-resistance to antibiotics in a range of different microorganisms. So what's happening to these microorganisms that are surviving on the textile and then going back into the healthcare environment. Next slide, please. So we did a stepwise process whereby we subjected the microorganisms to we did Klebsiella, Staphylococcus and Pseudomonas, and we looked at if we subjected the microorganisms to a sublethal dose and trained them to become resistant, how far did this go? So it was a sublethal dose of a non-biological branded detergent. We didn't do the biological one for the pure fact that the enzymes would interrupt what we were looking at. It would messy the message a bit, if you like. So we stuck with the non-biological detergent, and a well-known brand that's commonly used. And what we did was we did an 80% inhibition growth as our sublethal dose, and we grew them overnight in the culture with the detergent. And if they survived and we were looking for an optical density above 0.1, then we'd increase that dose and just repeat, just keep letting them passaging them in increasing concentrations of that detergent up to 20 passages. We would then look at cross-resistance to antibiotics at every 5 passages that the bacteria was able to survive. Next slide, please. So what we found across the 3 microorganisms, and I did forget to say there that we looked at both powder and liquid detergent. I think the end column is most probably the most significant, the percentage increase. And we had phenomenal increases in what we could train the microorganisms to. Now, we've got to remember this is a detergent and not a disinfectant, but most brands of laundry washing powders or liquids are just disinfectants. So we even had one there, 1 million in the Pseudomonas. It was going right up that 20 passages. And what we then did, as I said, was we looked at cross-resistance. So what we can see in this diagram is the zone of inhibitions. The green bars are where the microorganisms are susceptible. The orangey coloured bar is where they're in the resistant zones of inhibition, and then the white, like the intermediate. And the blue dots are where the microorganism started with its resistance before it had been subjected to the domestic washing powder or liquid. And the orange is where it was after the passages, the top passage, that it was able to survive. So what we saw here was, we didn't see in the Pseudomonas, because this is Pseudomonas, we didn't see many resistances occurring in the Pseudomonas, but what we did see was a definite trend to being more resistant to antibiotic, but we never, there was no clinically significant resistant strains developed or trained during this experiment with the Pseudomonas. Next slide, please. However, when we move to Klebsiella, we start to see larger changes between the blue and the orange dots on the figure, and we are seeing some of them becoming resistant to antibiotics. So if we look at cephalothyn there, you can see that that's moved quite significantly in both the liquid and the powder state. Meropenem as well, meropenem. So we were seeing at least 2 or 3 resistances having been developed in the Klebsiella, just being subjected to the domestic laundry powder. Next slide, please. However, when we move on to Staphylococcus aureus, we really started to see a lot of resistances emerging, and clinically we'd gone from an MS strain to an MSRA strain. RSA strain, get my acronyms right. So we developed an antibiotic resistant strain here, which really was quite worrying. Next slide, please. So we put on this table, because obviously there's a lot on that diagram, what we were actually seeing, so which isolates that produce clinically relevant resistances. And as I said, it was mainly in the Staphylococcus aureus and a little bit in the Klebsiella, but we'd seen a really big change in some of their profiles to these antibiotics. Okay, next slide, please. So we then did whole genome sequencing of antibiotic cross-resistant strains, and we did that at passages 0 and passages 15 for both the Staphylococcus aureus and the Klebsiella. And again, we did DNA extraction, but this time we did shotgun metagenomic because we wanted to see those smaller mutation variations so that we could understand what was actually happening within the strains that had become resistant. Next slide, please. So Novogene did all of the analysis again for us and sent the data, which Caroline's on the screen there, who's going to be answering any questions you might have about this at the end. She then analysed the data that was sent back from Novogene. And next slide, please. So what we saw was that both in the Staph aureus and the Pseudomonas, that we were seeing after liquid and powder detergent, depending on which strain it was powder for Pseudomonas and liquid for S. aureus, we were seeing MGRA in Staphylococcus, and we were seeing ACRB in Klebsiella, but both of the genes that were significantly changing with these were associated with efflux pumps. So this goes back to very closely to what we were seeing in the microbiome of the washing machines themselves. So this was quite interesting. Next slide, please. So we have published this paper, so it's open access. So if you're interested in reading the full study and looking at the data a little bit more closely, then this is the paper which you can access. Next slide, please. So what we recommended in this paper, there was recommendations for both healthcare workers and the employer, but ultimately is that short cycles shouldn't be used. That really, if we're relying on thermal disinfection, we need to be choosing a 70-degree cycle, because domestic machines are just not reaching the 60-degree. Whether they would reach some 70 degrees is questionable. That actually the washing machines themselves need to be regularly disinfected, so they're not contributing to any of the transfer from the machine to the textile back into the clinical environment. That definitely we shouldn't be mixing laundry with any home items, laundering items, because of cross-contamination. And actually we need to renew domestic washing machines if they're being used in what I would call high-risk environments, not necessarily just for cleaning family laundry, every 4 years, because we really start to see a decrease in the performance of those machines after 4 years. But really, that's putting the onus on the healthcare worker, which Is that fair? I don't know. So the employer, we also put forward some recommendations that really they should be providing detergents that are disinfectants to healthcare workers that have been in the laundering at home, so at least they know that there is a significant detergent going in there, and that will contribute to the disinfection of the textile, but also the maybe the build-up of the microbiome within the machine. That actually they offer servicing and performance monitoring of those machines if they're not going to provide industrial and on-site laundering. And my preference would be that they do offer on premises or commercial laundering, because these are regulated and validated and maintained so that they know what the parameters are and that they are being met. The other issue that a lot of nurses have is the care labels don't always allow for that high temperature laundering. So the uniforms that are sourced must be ensured that it's viable to launder them at those higher temperatures. And that ideally that it's regular renewing again of machines, and where does the cost of that come from? Okay, next slide, please. So in conclusion, microorganisms can survive on textiles and through the domestic wash, particularly at lower temperatures. Domestic machines do not perform to their set thermal disinfection, and the users have no idea that this is not happening. That actually our domestic machines do harbour antibiotic resistant genes, and they can become resistant to non-biological washing detergents, which can lead to cross-resistance to antibiotics. So I don't say this to scare everyone into not wanting to use their washing machines. That's not my intention by any stretch of the imagination. And I think just for our domestic laundering, it's fine. But where we're really raising this issue is where we've got healthcare workers that are known to be bringing those microorganisms home, or you've got vulnerable members living at home with those healthcare workers, because obviously there is issues with the potential for cross-contamination here. So next slide, please. Just wanted to thank the TSA, who's the Textile Services Association, for funding the research alongside partners in America, the TRSA, and the team that did the work. So I'm talking about it, but it's the royal we. So we had the team. So we've obviously got Caroline on the call here, but Lucy, Ray, Jake, the dissertation students that were all involved in collecting this data, and also to Novagene for letting us share research. That's it. Questions?
Thank you so much for that talk. That was really brilliant, Katie. And again, it's so pertinent, and because in terms of we all have people who like in terms of some of my family are healthcare workers, so even the I suppose the pertinence of this to kind of, let's say, even like or like it's so kind of relevant and important, and it's very thank you for that excellent talk. I think, as you said, from that, I think I'll ask a few. Well, we've had a couple of let's say questions from the audience, and I'll put these to you and Caroline, if that's okay. But yeah, no, thank you for that. Thank you for that excellent presentation. It was so useful. So in terms of, sorry, there's a few we can kind of look at. I'm just trying to think of the person to go first. So I suppose in terms of, let's say, even from healthcare institutions, like even from the NHS or even worldwide, I guess it's more, one question is in terms of, is there any way of kind of, let's say, how you not mandate industrial laundering in terms of, but let's say how you kind of, is there any like kind of, I suppose, kind of like from a policy perspective for like the NHS or anything, how they kind of try and maybe mandate industrial laundering or increase the scale of industrial laundering, so to kind of prevent this this kind of, in terms of, is there any, let's say, from going forward from that perspective, like I suppose, is there any policy elements that could be kind of improved to this?
Well, there's the workwear policy, which says 60 or 10 with detergent gets rid of most microorganisms. There's no move at the moment for the NHS to change that policy. You can have on-site laundering as well, so what we call on-premises OPL laundering, which has used to be the case in hospitals many years ago. So they're basically the nurses' uniforms are taken to these on-premises laundrings, and they're industrial machines, so they're able to be validated and maintained, and then they would collect the laundry. But things like scrubs and bed linen is all in the NHS, all industrial laundered anyway now, so that's already occurring. But or the other thing is that they send it out to industrial launderers, but there isn't a move at the moment for that.
Okay, so yeah, sorry, so we just have a few questions. So to make sure about the microbial source of contamination, do you directly streak a piece of cloth on an agar plate? This is the first question on that. And how do you make sure that the microbial source is actually from a cloth or from the washing machine? I suppose in terms of the question is more in terms of is it more is let's say from let's say some of your is it more let's say from the clothing, or the washing machine is often where the kind of the source of contamination is coming from? For instance,
well, when we did the bioindicator one, we definitely know that that's the kill from that microorganism because it's obviously contained. But in terms of the swabbing of the machine, we don't know precisely where that source of contamination has come from. So it could have come from the water, it could have come from the domestic environment, it could have come from the textile. So Caroline, I don't know if you've got anything to add to that particularly.
Yeah, I'm pretty sure I've seen some papers saying that they think a lot of microorganisms we can find on machines are coming from us. So they think it's from the textile because we transfer our microbiome to the textile, and the textile is going in the machine, and the machine is just contaminated with that. I'm pretty sure I saw some papers about it. And my guess will be the water will bring some anyway, but it's probably less contaminated because the water is treated in most countries. So you have less organisms, but it's not sterile. But yeah, my understanding from other papers is that they think it's mostly the person bringing the bacteria in the machine.
Sure, no, that's really interesting. I'm kind of amalgamating two questions in one a little bit in this one. In terms of, so basically they just healthcare workers in terms of, so would they recommend liquid or powder detergent? And I suppose the second element of that was in terms of do enzymatic or oxidizing detergents show better decontamination performance?
We didn't
So there might be a
test. Yeah, no. We obviously tested only non-biological, but when we looked, if you go back to the slides where we did the kill in the machine and we looked at, I'm going to go back to it on my side so I can actually tell you which one's better. It's all right. We saw, because we looked at biological and non-biological, so obviously the biological's got the enzymes in, and generally looking at this, we only very slightly actually, we saw more failures with the biological detergent, but I wouldn't say that was significant, to be honest with you. It didn't seem there was a great deal of difference between the biological and non-biological when we're testing it against the Enterococcus in the wash system. So,
and seeing about making them resistant to antibiotics. So when we did the passages, it was easier to make them resistant with a liquid one than the powder. We reached lower increase with powder. So looking at that, we'll think maybe the powder is better because it's harder to make it resistant to it. But only reservation with that is I know that when you put your powder in a machine, there's always remnants in the drawer. And I think the machine doesn't dissolve as well, the powder. So I'm not sure that you dose anyway correctly with the powder as well as the liquid. So it's a two-sided problem. So powder seems to work a bit better in terms of not allowing resistance, but is the machine is really able to dissolve it properly to have the optimal effect of it? So
When you said about oxidizing agents, we also did a whole range of disinfectants from the industrial laundry industry to see if we were able to replicate what we'd seen in the domestic machines, but we couldn't because we were having to go, the dilutions to get to a sublethal dose was so great that and even then we were only able to do 1 or 2 passages, so we weren't able to replicate this with like stronger disinfectant sort of commercial detergents.
No worries. Okay, we have a few more good questions as well, if that's all right. So in terms of, I guess, again, another kind of like amalgamated question in terms of how significant is the role of improper laundering, in your opinion, in terms of the spread of antimicrobial resistance and let's say the hospital-acquired infections, and in terms of what, let's say, from your point of view, what specific pathogens, I suppose, are the most resistant and the most, I suppose, worrisome kind of going forward?
Okay. We always get asked this question, what's the risk? And it's quite a hard one to answer, but what I must say is we've got a lot of research going on at the moment that's looking at transfer of microorganisms from textiles in a range of different ways. So we're looking at bed making, we're looking at when you're wearing a garment and the shedding from movement, and we're also looking at transfer from textile to skin. So we've got quite a lot of that research currently going on. So watch this space, because that is the question, what is the risk? But it's a very hard risk to do a direct causal link with, because it's quite far removed. And if someone in hospital comes down with MRSA, well, was it from the environment, or was it on the uniform? We just don't know. So yeah, so that's ongoing. And I've forgotten what the other bit of the question you asked me was.
I suppose about pathogens, in terms of any pathogens, particularly, let's say, is there anything, let's say,
spores, absolutely spores, because they're just not removed by temperature, they're not removed by the disinfectant. The work we've done on C. diff, it's able to produce like little appendices that actually cling on to the textile. The longer they're on the textile prior to being washed, the harder they are to remove. So that's definitely something that needs to be addressed.
No, that's great. And I suppose the next question is kind of almost kind of follow on to almost what you were kind of indicating, in terms of, let's say, like further study, and in terms of where kind of what's lacking in understanding, I suppose, in the risks at the moment, and in terms of for your future work, like what avenues you'd kind of like to kind of pursue in that to kind of help bridge those gaps, I suppose.
I think the transfer one, which we're on, is quite a major one. But Caroline's also doing a lot of work around spores in the next few months as well, just having a look at spores and how we disinfect those within wash systems, and what the best way of doing that is. So I think they're the 2 areas that we're currently focused on.
No worries. No, well, thank you. As in terms of, I think I think in terms of if there's any questions that I haven't answered yet, I'm sorry. What I'll do is we'll get them answered for anyone in the audience afterwards. But no, I really want to say thank you both very much for your excellent presentation and like insightful follow up to the questions we received. It's been a really excellent kind of an informative hour. And we're really glad to. And as I said, for any follow-up questions anyone in the audience may have, please send them through just to Novogene as well, and we can pass them on to Katie, or we can try and answer them ourselves as well if needed, if it's more a sequencing question. But as you said, in terms of, please feel free to kind of, we will send all the slides through, and we'll send the slides through and the recording through in the next day or two. This will be on the website in the next day or two as well, so it'll be there to look at for whenever needed. But it's been but again, I basically want to thank Kitty and Caroline for their for agreeing and giving their time for this and presenting this very interesting work. So, and we're glad to work with them, and we hope to continue our collaborations going forward. But no, I think from that perspective, I'd like to say goodbye to everybody, and thank you for your time. And we look forward to joining us again on our next webinar. So
Thank
thank you
you.
very much.
Thanks.
Thank you. Bye-bye.